Okay, so hi everyone. So good afternoon, good evening for others, and good morning for me. So welcome to the session 7, and we have here 4 papers presentations. All the authors, all the presenters are here, and then as we approach 50 minutes past whichever hour we are here now, then we start the live discussions. Okay, so good luck for the presenters, and hope we have good questions. Okay, that's with you now, Elias.
Okay, thank you. Let me share my screen. Can you all see my screen?
Yes.
Yes. Okay. Okay, thank you. I'm very happy to present this paper, which was a very nice joint effort with Thomas, Dani, and Patricia, who are also in the audience, so they can also help me answer any questions you may have. So we were triggered by the question, how do we evaluate self-adaptive software systems in this work? For the impatient that ask really, how do we evaluate self-adaptive systems? I have one summary slide here. So what we can say is that we mostly use experiments to evaluate the effectiveness of new integrated feedback loop approaches by comparing the new approaches to one or more baselines, using actually a variety of managed systems under mostly predefined changes, mostly in the execution context. Okay, so I'll try to unpack all of this in the rest of 4.5 minutes. So our motivation here was that we felt after about 2 decades of SIMS and self-adaptive systems research, it's important to understand how new contributions are evaluated in this area. That's important because then researchers can better compare new findings, and we can incrementally build and consolidate and solidify the body of knowledge. However, we found out that even though there are a number of overview, systematic or not, of contributions of adaptive systems, there was no overview of how evaluations are conducted in self-adaptive systems. So to fill this gap, we performed a systematic mapping study. The design of our study looks like that. So we focused on the last 10 years of SIMS and only SIMS. We filtered out the papers that were not full research papers, so we only looked at full research papers, and also for papers that were not contributing with a secondary study or overview. Then we selected only these papers that contained at least one experiment. By this, we meant that there was a quantitative comparison between two experimental configurations in the evaluation part of the paper. Around 65% of the papers included at least one experiment. Some included more than one. And then for each paper and for each experiment, we extracted several data items and we created the paper and the results here that I will show. Our research questions were first, what is the scope of experiments? Second, what is the design of experiments at SIMS? How are experiments operated? How is the experiment data analyzed? And finally, how are the experiments packaged? We followed actually the well-known experimental process from the book of Volin, Experimentation in Software Engineering, which mentions the exact 5 stages of a controlled experiment. Of course, here we talk about technological experiments, not human, not controlled experiments that involve humans, but the terminology still applies. So I'll just give you a highlight of some important results. First on scoping, what is the target of evaluation? As I said in the first slide, we mostly evaluate new integrated feedback loop approaches at SIMS. As you can see in the slide, there's also an increase in the learning methods that have been contributed and evaluated via experiments at SIMS, and less so of planning and analysis methods. And really, there's a scarcity of monitoring methods and execution methods that are contributed to SIMS and also analyzed by an experiment. Second, we mostly also evaluate the effectiveness, meaning whether a new approach works or whether it works better than some other approach. We also evaluate the learning ability, meaning the accuracy typically of this learning related experiments in these cases. We also evaluate the time efficiency, meaning, for example, the performance or the planning time of a planner, etc. And less so the other qualities like scalability and robustness. Now, one highlight here is that we looked at are there any patterns that we can say this is a typical case for a SIMS experiment, and we've indeed found some. In the paper we mentioned 4. Here I would briefly describe 2. So the most common pattern in SIMS experiments was an experiment where 2 methods of the managing system would be compared to each other. Typically, one would be the proposed method, and the other one would be a sort of a baseline. And what you would measure in such a case, you would measure the resource utilization and the time behavior of the managed system. So we found this.
Sorry to tell you, time is up. Can you try to conclude?
For sure. that was very short. Okay,
it is.
I have 3 slides. Uncertainty is represented, as I said, mostly via predefined scenarios related to context. And this is my final slide. And one of the things that I didn't mention before is that we also found that even though stochastic behavior of adaptive systems calls for statistical analysis methods, we found that there are papers that and experiments that use statistical tests, but many times the choice of statistical tests is not motivated. Finally, we found that there are replication packages, but most of the times they're not full-blown replication packages. And this is something that can clearly be improved and help in future research. Thanks.
Thank you very much, Elias. Now, Dimitri, the floor is yours.
Okay, hi. So it switched to a different screen, but I will do the short pitch now. So my name is Dimitri, and this is joint work with Liliana from UCD Ireland, and together with my colleagues Laurens Sion, Wouter Joosse. So this is about threat modeling. Threat modeling is an analytical approach that typically takes place early in the development life cycle, where you create an abstraction of a system and you envision potential threats to the system. You assess the likelihood, the feasibility of these threats, the potential impact, and you try to mitigate them up front. So traditionally, when you look at the software engineering life cycle, the security development life cycle, it is taking place during the design stage. And so the key question in our paper is, does security and privacy by design mean that you have to stay within the confines of this early stage of architectural design of a system? Or can you also meet the principles of security privacy by design by creating systems that are more flexible and can decide at runtime how to mitigate potential threats, that they can reason about potential threats? And so we start from our history and our background in threat modeling, and we look at what it would take to put that activity away from the design stages, from the drawing board, into the runtime of the system. And that's the vision that we put forward in the paper. What we propose concretely is on the one hand, a thing called reflective threat modeling. So we want the system to maintain a view on itself. It's an architecture runtime inspection model that we want to build and maintain. And that's a significant departure from the type of models that are currently used in threat modeling. And so for that, we would need integration of approaches of reflection, monitoring, inspection. And I see also in the next presentation that this is a topic. And building upon that, we would also need approaches to do end-to-end adaptive threat management. So the advantage of threat modeling is that you keep an end-to-end perspective on the system. You reason about risk from an entire system perspective. And this contrasts a bit with adaptive security privacy techniques that we currently see in the market, which are more localized. You have, for example, an adaptive firewall that can react upon certain things, but it does not enact a system-wide change. And so in our vision, we see that systems are inherently increasingly built upon reconfiguration facilities that are powerful. Think of container orchestration, deep types of runtime adaptive systems. We want to build upon these types of frameworks to make this vision reality. Final slide. So this is a vision, this is ongoing work. So we are taking some steps in that direction. For example, to do runtime inspection of a system and to consolidate that into a model that is then subject for automated threat analysis. We have a tool and a framework called Sparta, which already takes some steps into automating risk assessment and calculating the entire risk profile of a certain system in a certain state. And so the grand vision that we here propose is that we want to promote the activity of threat modeling from something that is performed by analysts and architects in a by design context in an early stage of the development lifecycle into something that the system itself uses continuously to evaluate and reevaluate risk and to steer and to steer mitigations and countermeasures from that. So it's a short introduction. I will be very happy to discuss the paper with you in more detail based on your questions.
Great. Thank you very much, Dimitri. That's really on time.
Great.
Fantastic. So now it's Matthias. It's your turn.
Okay, I'll try to share my screen. Can you see the slides?
Yes, yes, we do.
Right, good. All right, I'll then briefly present the work that I did with my colleagues, Thomas Brandt and Professor Holger Giese, on improving adaptive monitoring with incremental runtime model queries. And to provide a bit of context, we assume a MAEP K-loop and specifically a graph-based architecture runtime model as part of the knowledge base, which is extracted from a monitored system via system sensors, and which can be queried for symptoms that may indicate the need for system self-adaptation by different query mechanisms. In previous work, my colleagues have introduced an improvement to the monitor task, which is called adaptive monitoring, and which basically has the aim of allowing the query mechanisms during query execution to influence the activation and deactivation of system sensors, with then ultimately the aim of being able to deactivate system sensors that measure data that isn't actually used during query execution. While generally this adaptive monitoring approach is agnostic to the employed query mechanism, its effectiveness still is dependent on it. And therefore, recently we have explored the combination of the adaptive monitoring approach with a very popular query mechanism, which is called RetiNets, and which is widely used in the context of model-driven engineering. The basic idea behind RetiNets is that a query specification is decomposed into such a network of primitive subqueries and operations such as joins that you can see on the right-hand side. And the problem that we found in combination with adaptive monitoring is that the primitive subqueries that are part of the RetiNet basically globally access the runtime model during query execution and access all the elements in it. And therefore, the adaptive monitoring often almost degenerates to monitoring everything and thereby activating all the system sensors. So in this work, we have tried to address the question how to enhance the Reti query mechanism to better exploit the adaptive monitoring and thereby minimize sensing effort and potentially reduce querying effort. Our approach there is an automatic enhancement of existing standard RetiNets, where we insert what we call projection filter structures, which are one of which is highlighted on the right here, into the existing RetiNet, with the aim of introducing some sort of or some degree of locality during query execution and thereby avoiding this activation of all the system sensors. We have prototypically implemented our approach and evaluated it in the context of synthetic simulated architecture runtime models of an online auctioning system. And as you can see here, our enhanced RetiNets, which are displayed as solid black lines or dashed black lines respectively, significantly outperform the standard RetiNets, which are displayed as gray lines with respect to both sensing effort and querying effort. So in conclusion, our contribution in this paper is an enhancement of the Reti query mechanism to better exploit our previously introduced adaptive monitoring approach and thereby minimize sensing effort and potentially also reduce querying effort. I say potentially because one of the limitations of this approach is actually that in some cases, the enhancement of the RetiNets may increase the querying effort instead of decreasing it. However, the monitoring effort would still be decreased. Another limitation is that previously we were able to treat the employed query mechanism completely as a black box. That is not possible anymore because we have to modify the employed RetiNets. And well, not a limitation of the approach, but maybe of the current work is that our evaluation is very simple, which is why in the future we plan to extend it and also consider monitoring activation times. And finally, we will try to lift some restrictions that we currently impose on the RetiNet structure that acts as a baseline for the enhancement. All right, yeah, that's it. Thank you for your attention, and I'm looking forward to the discussion.
Thank you very much, Matthias. Now it's the turn for Huma. Huma, the floor is yours.
Okay, so let me just share my screen. Is the screen visible now? Okay, so is it visible?
Yes.
Okay. Okay, so thank you, everyone. So today I'm going to present RDM-SIM, which is a remote data mirroring exemplar for evaluation and comparison of decision-making techniques for self-adaptation. First of all, what is remote data mirroring? It is a disaster recovery technique that is used to protect data by storing multiple copies at different physically remote servers. And it also tolerates failures by requesting or rebuilding the lost or damaged data samples from one of the active mirrors to facilitate data recovery. Now, why remote mirroring simulator is needed? There have been considerable research efforts that have targeted the domain of remote data mirroring. So therefore, comparisons between the techniques are needed. Secondly, RDM applications are very costly to implement, as the equipment used to install such kind of applications is quite expensive, and there is no exemplar available to support research based on the RDM paradigm. Next, I'm going to discuss about the operational model on the basis of which we have developed our RDM SIM exemplar. So the main goal over here is to copy data remotely by distributing the data across the network. And where the RDM network is required to switch between the different topological configurations, such as the topologies that we have considered are MST topology, minimum spanning tree topology, and redundant topology. And these topologies have different impacts on the different quality objectives, such as minimization of operational cost, maximization of performance, and maximization of reliability. For example, MST topology supports the satisfaction of minimization of operational cost and maximization of performance, whereas it has a negative impact on the maximization of reliability. And redundant topology has the opposite impact. And these quality objectives, we measure them in the form of, meaning, for example, minimization of operational cost is calculated in the form of, is measured in the form of bandwidth consumption for the network. Performance is measured in terms of time to write data in the network, and reliability is measured in terms of the number of active links in the RDM network. Next, I'm going to discuss about the architecture for the RDM SIM exemplar. So it is the architecture is actually used to facilitate the implementation of a two-layered architecture for the self-adaptive system, in which there is a managing system implemented on top of the managed system, which is RDM SIM in our case. The managing system is typically implemented with the help of a MAPE loop that makes use of typically different intelligent algorithms. And the managed system over here, which is our RDM SIM simulator, it is composed mainly of three main components over here. First of all, the management component. The management component acts as a bridge between the external managing system and the other internal components of the RDM SIM simulator. It has two main subcomponents, probes and effectors, which are the actually interaction points with the help of which the external managing system can collect data from the RDM network and will be able to execute or apply its decisions on the RDM network. The network component is actually used to implement the different physical elements of the RDM network, such as the number of mirrors, number of active links, topological configurations, and different monitorable metrics that are used to measure the different quality objectives. And the simulation component is related to implement the different simulation properties, such as different simulation runs and different dynamic environmental context for the RDM network under which the RDM network will be performing or working. As part of RDM Sim, we have actually implemented different uncertainty scenarios that represent the different dynamic environments for the RDM network. For example, the default scenario as 0, it represents an environment envisioned by the requirements experts, and it represents the RDM network working under normal conditions, where we consider that everything is going fine and all of the quality objectives meet the required threshold constraints. Then scenario S1, it represents unexpected packet loss during the execution of MST topology. That can happen due to the link failures, because of the failure of the different equipment in the network or something like that, and it will affect the reliability of the system.
Huma, I'm sorry, time's up.
Yeah, okay, I'm just going to wind up. Okay, so the other scenarios that we have, for example, scenario S2, that represents unexpected packet loss during RT topology. Over here, the unexpected packet loss can actually lead to unexpected meaning rate of data forwarding. That will have an impact on the operational cost and performance of the system. Scenario S3 is a combination of the other two scenarios, and similarly we have scenario S4 and S5 that represents a combination of S1 and S2 along with other disturbance levels that are introduced to impact the performance and reliability of the system. We have actually a demonstration video. You can have a look at that on Cloudar. Because of time, I can't play it right now. Thank you so much. Okay, thank you for your time.
Thank you very much, Huma. So now let's go through the questions. Okay, so Elias, there are quite a few questions to you. So we start with those that have questions to you. Start with Rogerio, and then followed by Ingrid, and then Sona.
All right,
Rogerio.
Elias, although you are the presenter, this question is essentially for all the members, all right, of the authors of the paper, all right. I take the scope that you focus on SIEMs in the last 10 years, all right. But my basic assertion here is that perhaps you're doing not a favor to the community as a whole, all right. Because in the sense that there is a lot of work on evaluation outside SIEMs that has been completely ignored in your study. And since SIEMs is a reference, all right, what might happen is that people will refer to your paper and they're going to ignore the work that's been done outside. So if we want really to expand the self-adaptation to other communities, I think it's quite dangerous, actually, to be so narrow in a study, all right? In the sense that you look into because I've got examples, all right? Examples that go against some of the statements of the presentations, both by Elias and by your recorded video. There is systematic evaluations actually being performed in terms of dependability and security. There is evaluation of robustness of controllers, right, which were completely ignored in the study. And it's a shame, all right? It's a shame because it was a lot of work being done there. Those studies were published elsewhere in conferences, related conferences, all right, or specific journals, all right, or special issues in which not related to self-adaptation, but it was an effort of the community to go other way. Now, what I see now is that you are inputting only to SIEMs. What it matters is SIEMs, and all other things are rubbish, essentially. All right. And this is a culture that perhaps you should break here. If you want really to see how a community to expand, all right, this, in my view, these studies are dangerous. So, and I'll stick to my question, all right, whether do you agree with my view is a fair or not a fair assessment?
Oh dear.
Well,
Okay, now I have a debate here. Okay, good. Go there,
do I need
then
to
Thomas, and then Danny.
do I need to bring the big guns, or shall I answer? I can try. I can give you my view. Rogerio, yes, thanks for the comment. We did not neglect the first of all the point you mentioned about the robustness experiments. We do not neglect them. We simply mapped what is there at SIMS. Now about the SIMS, yes, we know there are there's a threat of the selection when you select the venue for the study. That's why we were very careful in the threads of validity and in explaining from the beginning till the end in the paper what we did. Now, if one reads Fast and Furious and wants to make their own somehow conclusions that we did not conclude, that's I think that's a problem of the reader, not of the study per se, because we were very careful. Actually, we did also a protocol. We did we had the protocol reviewed. We were very aware of this limitation in the end of the study, but we had also in the end 82 papers, 140 experiments. We extracted looking in how the experiments are done. So we essentially had to understand each experiment. So in terms also of effort, it was infeasible to do more at the time frame we had. And I leave the floor to the others if they want to add something.
Yeah, if I may add, because this is related, I somehow agree with Rogerio, but to lesser extent, right? I do believe that it is useful for the community, but could be enhanced, right? By looking at
for sure.
Other communities that we could learn from, right? Otherwise, we would stay with the same sort of approaches for evaluation that we have done in the past, right?
Yes, so, I agree on that. Yeah.
So besides like looking at other communities, I also suggest to maybe put this on a website so you can update. Others can also contribute to this, and this could be somehow evolve into a useful document, especially for newcomers. So this could attract others to also see what kind of approaches for evaluation they need to consider.
Thanks a lot, Pujan. Sorry, Janine, I have to answer also to Rogerio's comment on the chat because
no, but I think Patricia and Danny as co-authors,
yes,
I think they want to answer something.
Yeah.
Yes, want to say something. Yes.
Thanks.
Very shortly, and I'm happy of the intervention of Pujan. So it was our intention that we as a community learn from works done, and it's of course not only the SIMS community, but we had to scope down and start somewhere. And this is also a call for actions that from other communities or for this community to actually expand and replicate the study so that the learning goes further.
Yeah.
Okay, Danny and Thomas.
Let me add a few things here. If we would expand the scope, we would have, of course, more compelling and more evidence for what we state. Now, this study has a scope, as any empirical study has. Empirical studies are not giving an answer, a final answer. Empirical studies are giving an answer within a scope, within assumptions, within boundaries. Our scope was SIMS. We want to understand how do we evaluate within SIMS. We were not interested how they evaluate within I don't know what else. Our scope was SIMS. So we looked at papers from SIMS. And that was a hard effort. Besides that, we discussed this issue, Rogerio. We discussed the scope, absolutely, in the beginning. In the beginning, we said, shall we do 5 years? And shall we look also at that and that and that and that other related conference? At the end, we decided we do 10 years. Actually, we first did 5 years of SIMS because it was a huge effort. And gradually, we increased the numbers. We said at the end, let's take the full symposium time. And Thomas and Ilias in particular pushed through to get all that data collected. We also thought, let me end with a joke, who knows that our paper might be invited for an extension for task special issue And then we can include a few other venues.
Okay, Thomas.
Yeah, I think I just had one thought on this, but now Danny distracted me with this thing. Yeah, so we really want to have a look at the SIEMS community, and I mean the data we collected is also not like pessimistic. We show we have improved over the last 10 years a lot. This was not visible now from the presentations maybe, but if you look at the paper, we see we improved a lot with experimentations, and I think there's still room to improve. So it's not like we say that's the way you should be done the experiments. It's more like describing the current situation and pointing to what can be improved for future experiments. And I think that's really also important aspect, because the reproducibility issue is not only an issue with providing the package. We struggled really often a lot in understanding really the experiment if you want to rerun it based on a paper description. So we really have to improve. Often research questions are not explicitly posed. The independent variables of experiments are not explicit. So that was really a huge effort to extract this from the data. It's like a reverse engineering we did. And I think our community needs to improve here by making things more explicit with the experimentations we do. So it's not like, it was not about, of course, there are papers in other conferences as well. And it was not like getting like best practice out of it. It was more like understanding what's the current status in our community. That was essentially the primary goal of the study.
Cool.
So maybe Rogerio is not even more pessimistic, but
Rogerio, I can give you 1 minute for you to counter-ask. 1 minute only, please.
First is Elias. You want to, because I wrote something on the chat.
Yeah,
and you want to mention something.
yes.
And I'll
exactly.
mention. Yeah. Okay.
Thanks a lot. About the slide. I just wanted to mention that indeed we had a lot of results, as Thomas said. So essentially, the pitch was a view over the presentation, which was a view over the paper, which was a view over the results even. So so maybe some things were explained too fast in the pitch, but I think that in the paper we try to explain the scope in a careful way. I understand your point, Rogerio, of what an impression this can have, but I think that the way it's done, we had taken proper care of this particular thread.
Very nice. It makes now the paper even more attractive for us all to read it. Very good. Okay. So now Ingrid.
Can I react now?
No. Come on, have other papers here to ask questions.
Sorry. No. Because you gave me the word and I gave the word to Elias.
But it's your
Okay,
I mean,
fine. Okay,
your controller decided to give the control to him, so unfortunately the scheduler has to go on. We can go back to you, Roger. I'm sure that discussion will come back again. I'm sure.
Okay, so I'm going to be less mean than Rogerio. I'd like to make a comment on that, saying that sometimes people forget that a systematic review has a defined protocol, and then you define a scope, and it brings results considering this scope that was specified. And very often, this is the main complaint about reviewers in systematic reviews, that why didn't you look here or there? Like, we should define a scope, and it's good that you did this as a starting point, and I really would like to see people or you guys to expand the work and look at other venues. Having said that, so I think the work is brilliant to bring this into discussion. I would really like to see a panel actually on that, because this is a main challenge of our community. And then I have a question, actually it's 3 questions together. I wrote them, I can write in the chat to make it easier to answer it. So if we look at in the beginning of our community, like in the first years of SIMS, the main goal was to automate in a domain neutral way self-adaptation. So if you look, for instance, Rainbow, you have this framework that basically it automates something that can be done in a project by project basis. And many approaches at SIMS aim to do that. Like we can do that for a particular software project, but we can provide a solution that can be instantiated in different projects. And I myself, I faced this challenge in different research works I did is, how do I evaluate that? Like, you have this approach, what you can show, like with some examples that yes, it works, like it automates something that the developers would have done in a project. But what do I measure? Is the only way of doing that like experiment with developers that then I compare, like that I reduce the effort? So how do I evaluate this kind of thing? Second, considering that we have one or two projects or exemplars as we have in our community, how can we publish papers at ICSE, FSC, TSC in times where people need very large scale GitHub projects, which we don't have? And finally, do you think that this is the main reason why in our community we tend to publish more submit more short papers to SIMS? Because like it's so difficult to evaluate, like the rigorosity expected of long papers, like with an evaluation, is so high that people tend to go for short papers because they don't know how to evaluate. So I'll post in the chat these questions and yeah, sorry for the very long question. Questions.
Shall I give it a try, or Janina?
Oh, sorry?
Shall I give it a try to answer?
Yes, yeah, please.
Now? Okay. So yeah, quickly, I don't want to monopolize the whole thing. So so I think that it is always a matter of we would like to evaluate many times different things than we actually end up evaluating, because in the end, what we want to do is we have some time constraints. We want to finish the paper. We want to do the research, and this takes a toll on the evaluation. So we want to evaluate, full-blown things in a realistic system, and mention also planning time and everything, and robustness and scalability, and not only efficiency, or effectiveness. In the end, it's a trade-off between the time we have, the resources we have, and bringing it there. And now the question is, what do we want to have as a community? Where is the bar? Because it seems the bar is somewhere around, if you can compare it to something else, and so it's kind of better, you pass. And you have to compare it also. That's another result I didn't have time to do. So the last 3 editions of SIMS, we found out that every new approach that was suggested was evaluated, was compared to something. If you don't compare it, you're out. So this is kind of the rules now of the game of the game of publishing at SIMS. But the point is, where do we want to go? Yeah, and yeah, exactly as Bojan says in the chat. What is the bar that we want to set? And I believe if we set higher bars, or let's say are very kind of meticulous about how we specify an experiment, like Thomas said before, we can reach evaluate full papers and evaluations that are broader and more convincing. It's a little bit of a matter of engineering the evaluations, I would say.
So maybe the point is we as a community should specify what are acceptable evaluations, and the PC chair should share that with the reviewers. I don't know. I interrupted someone.
Okay, cool, very nice. So Sona.
Yes, my question is also for Ilias or his co-authors. Thanks for the talk, Ilias. I was wondering about this uncertainty analysis that you did in your study. Also, having done such studies myself, I know that it's not very straightforward to really quantify these notions and extract them from those papers. I was wondering how straightforward was it to kind of locate its source in the studies. Maybe it's not always very well documented. And then also regarding Thomas's comment that you said you observed some improvements over the years in treatment of certain phenomena in evaluation. Did you notice some raising attentions towards capturing uncertainty as a first-class phenomena, as you mentioned, or what are your thoughts there?
Yes, I can answer quickly. Yes, we did. So uncertainty is much more a first class concern in the last 3 to 4 years compared to the previous years. I believe this is also because there is a better understanding of what this uncertainty is and why it's so central, and in general and at other systems and in evaluations of them. Second, yes, the uncertainty data item was the hardest by far, I would say, from all the other data items. In the end, we ended up splitting this data item into uncertainty representation, which is how did the authors resolve the uncertainty while designing their experiment, and in scope of uncertainty. So what did the uncertainty capture? What did it model? Was it about the system, or was it? These were the two. I didn't have so much time to explain on the graph. So these were the two dimensions that came out of a lot of discussion, and it was not obvious. We also decided to disassociate the uncertainty items from the factors, because you see, because when you change something, it can be because of uncertainty, because you are interested in the results, or you're interested on their effects on your actual comparison. Right, so one is uncertain, the other is not, and in the end we ended up disassociating after quite a lot of discussion, saying no, these are two different things. Let's not mix them up. Yeah, but I can continue on for at least half an hour. I think Thomas as well, and Daniel as well, and Patricia as well. Only on this point. Very good point.
Yeah, I can relate to that. Thank you.
This is a very good discussion, guys. So Thomas, you would be the next, but I was wondering if I could switch a bit to the others, to Dimitri, and Matthias and Huma, and then we can have the round robin scheduler come back to you guys, because I think that this discussion will take over, I guess. But very nice. I mean, very nice work, guys. So I'd like now take the opportunity for Danny to ask Dimitri.
Hi, Dimitri. Good to see you here at SIMS.
Hi, Danny.
It was nice work, nice visionary work. I like it a lot, really. I was just wondering, I saw your whole presentation, a video, and there you emphasized that traditionally design, privacy by design, security by design, is really heavily relying on expert knowledge. And I was just wondering how you deal with that, because all this knowledge, expertise somehow now needs to be encoded or some form, or you say, no, it's not really the matter anymore. We have another vision on it as well. So I wonder where is this human expertise gone now in this new vision?
Thank you, Danny. That's an excellent question. So there are two schools of thought here. One side of the fence is you have all of these consultants that want to keep their job, and they want to keep getting hired to do these types of workshops within a company, and they are well paid. But on the other hand, we have been looking at automation in threat modeling, and some of those steps involve consolidating that expertise. So for example, we have worked out sophisticated risk models that take into account a wide array of factors that are usually also taken into account by an expert. They are not just doing it on gut feeling. They take into account what is the likelihood that this type of attacker will be able to enact this type of attack, what is the value of the asset. If you make all of these things explicit in the model, then a lot of this analysis becomes reproducible and more, well, you take out that role of the expert to some extent. So we are, I mean, it's an open debate, but we are leaning more towards that, especially when it comes to this type of improvement. But the bottom line is that software development is increasingly iterative. I mean, we used to have a very old-fashioned view on it, where you have months to spend on the architecture and design phase, and then you do the big bang, you solve all the problems, and then you go into implementation and everything is golden. But this is not true anymore. I mean, software is being developed through continuous integration, continuous development, changes a lot, evolves a lot. And so is the reality in which software operates. And we see attacker capabilities change a lot. So by the time you do this traditional cycle of architecture, where you think of what are the capabilities of the attacker, and you bring that software into operation, and then after a few months, that threat model that you did at the very beginning is outdated. And that's the motivation for this type of work. We want to bring that type of analysis closer to the runtime and keep these runtime things in perspective.
Thank you very much. Clarifies completely. Thank you.
Cool. Okay, Rogerio, would you like to ask a question to Dimitri?
Yes. So, so Danny, your comment about security by design. Actually, there is an initiative in UK in which actually starts from the hardware, the harm design, the harm processor, and look at the compilers and trying to formalize everything from scratch. Don't like from the top, but from the bottom, actually. All right. So a big investment here involving industry. Now, Dimitri, going to your work, all right. So I've got two questions, but I'll start the second question because perhaps the most relevant here is the threat analysis, all right, at design time. How much do you think actually the threat analysis of design time is actually effective, all right? Because we did some experiments using gamification, all right, on the self-adapt authorization system using games, all right? And we noticed that a lot of the attacks were new attacks, all right? They're new attacks. So it didn't matter what you thought before, all right? They were new attacks. Some of the attacks, our system, our self-adaptive authorization system was able to handle, but some of them will completely destroy the system, all right? To the point of restarting again, all right? So from your view, all right, and from what I understood from your presentation, your larger presentation, is that a lot of effort is going to be in threat analysis at the design time, all right? Which in reality, it becomes a bit weak, all right? Because at runtime, you don't know what's going to happen, all right? And which can completely destroy your system in a very easy way.
So that's a good remark. That's exactly the motivation for this work. So threat modeling originates from the traditional way to do software engineering, where you have to do things by design in the early stages, and then you can anticipate that somebody may try to tamper with some inputs of the system, and you can harden it, can make it robust in that sense. But we see indeed that because of the fact that systems are continuously online, we don't deliver software as products anymore, but as services. That's the way we are doing it. And they are exposed to the entire world. That makes for a reality in which things change really frequently and a lot. And you have to take that type of activity, that type of end-to-end risk assessment, you have to take it out of this typically one-shot threat analysis. But to answer directly your question, so threat analysis is effective in the sense that if you just allow software developers to create a system and not think about security up front, they will make typical obvious mistakes. That is, you have to sometimes at some point wear the black hat and think about, well, given the functionality that I'm accomplishing, how can you do harm? How can you abuse this functionality? That is something that needs to be done, and that's not the natural way of thinking of a software developer. So that's what the value of threat modeling is in this respect. Does that answer your question?
Kind of.
Okay, we can go back here to you, Dimitri. So let's give a chance now to Matthias answer the questions towards him. Danny, you are the first one to ask question to Matthias.
Matthias, thank you for your talk as well. I was a bit wondering, in fact, I probably asked you the question before at the previous presentation, but I still am a bit struggling with it. I can imagine there would be systems where optimizing monitoring is important, I can imagine. But I was just wondering, have you thought about it? Because you start your talk as if it is something that applies everywhere. In my experience, it's not applying everywhere. In many of the systems that I do, in fact, sensing is cheap, and I have no reason. It's probably more expensive to start regulating it than just monitor what you need to know. But I can imagine that there are cases where it makes sense. Can you elaborate a bit on the characteristics of systems where optimization of monitoring would be useful?
I
Hi, this is Thomas speaking. Can you all hear me? Thomas Brandt,
Yes, we do,
the
Thomas,
other
yes.
co-author. Yeah, I'm discussed with Matthias, so I take this question because my part is more on the adaptive monitoring, and I probably also helpful answering this question. So for this question, I thought maybe it's worth considering, first of all, the steps that this monitoring kind of comprises, like gathering all the data, then aggregating it to more dense values, transporting it, for example, to the runtime model, then storing it and executing the queries on those runtime models, right? And basically, you could argue that you can kind of deactivate certain steps of this whole chain. What I figured out during the time I was looking into the adaptive monitoring, especially this analyzing and aggregation of data, is the expensive or is often an expensive part of the work. So basically, and then you ask about kind of which systems would be interesting or where it is interesting. That's the case where metrics that I'm checking basically are pretty expensive, and those costs could be notional costs. For example, if I have low resources, let's say my sensor is battery driven, then maybe it, even though it's easy to, or it's not much effort to read the data point, if it's battery driven, then maybe it's more expensive compared to if the same sensor reads something in the data center with a normal power supply, right? So that's the one point. The other point is I came across cases where, for example, determining a certain value takes quite some time and quite some compute powers, like calculating certain values of collected data, for example, or executing certain scans of the system to determine a matrix. So, but I also agree with you, and that's also what other people also told me. They argue, yeah, we just collect just everything and then just throw it away. So one has to really look into the cases, and the answer to this question is basically it's most useful where metrics are expensive. And the other point is that where this approach is interesting is if properties that I'm monitoring are actually depending on each other. So if, for example, a certain value of a property determines whether other property is relevant or not, then basically that approach makes sense. And if I have complex structures which I'm looking for, or also if I change the structure of my system and I want to go, for example, in further detail, change the level of abstraction for certain purposes or at certain point of times, then this is useful as well. So to summarize, maybe expensive matrix play a role here, considering notional costs, not only actual costs, and kind of the queries that I'm trying to answer, or the patterns I'm trying to find. If they are complex, then this is also a helpful approach. I hope that kind of characterizes scenarios where this approach.
In fact, if I may add up here, it was not a question in terms of criticizing, by no means, the work. I actually like the work a lot. In fact, the question is more like a suggestion to next talk you give, to give a few compelling examples that show the reader, the listener, immediately like, wow, yes, this makes sense. And things that I think about is I'm working on IoT. Might make sense in IoT because sending messages over the network in a multi-hop network costs a lot of energy. Another example might be if you think about the discussions we have on uncertainty and unknowns in the community debate, you might say, okay, I want to measure a lot, redundant stuff, because then I can discover things that I might be interested in. I need to process it. It might all be quite expensive, and then you might do context-dependent changes in terms of what you want to monitor, and maybe some event might trigger to start sensing other events. It's in that context that I see use cases, but I was just missing use cases in the talk. You start just blunt, in fact, like here it is, and it is good, and it is important, but I was missing a bit the argument.
Okay, so we spend more effort on motivating.
Yeah, good. I mean, it's not a big deal, but
Okay.
I would, in fact, the second question, I will postpone it to Thomas, who was in the list also giving a similar question. So let's give it to him then.
Thank you, Danny. Thank you. Yeah, Thomas Boers.
Thank you.
Yeah, go ahead.
It's always difficult to distinguish whether it's TOMAS or THOMAS.
Yes, you guys just say Boers.
Maybe better. No, but very nice. No, it was more like thinking aloud, and maybe if you could have some comment on whether you kind of are thinking, or what would you thinking about somehow looking for a trade-off when you sense so that you kind of maximize or like the information value, or kind of like minimize the uncertainty of not sensing or sensing only a little. It's sort of, I mean, it feels a bit like some biased approaches, or I don't know. So kind of, I was interested whether you have any take on this.
First of all, maybe I have to explain that our goal is actually, and I think, was it in your question or Danny's question? Our goal is actually to detect all phenomena we are interested in. So, and the difficult thing here is actually the activation of the monitoring, because this activation also takes time, right? So if you figure out, oh, I need this value, and you need to kind of 5 minutes to obtain it, but my phenomenon only lives a minute, then I might miss phenomena, right? So that's an important thing. So the question here basically is, how do I control if my monitoring takes too long, which phenomena I can basically detect, yeah. But first of all, we then say, we kind of discussed it in the sense of how long the phenomena we need to exist in order for us to detect them, surely. But in case that kind of the time is an issue here, then we also have the possibility to say, okay, this property to activate the monitoring just takes too long, so we continuously monitor that. So that's kind of a trade-off to decide if the activation takes too long, then we can monitor that all the time. That's a decision that kind of the user needs to take, right? And that depends a lot on the phenomena he tries to or she tries to detect, basically.
Thank you.
Okay, good. Okay, guys, so I'd like to jump a bit the queue and have a question to Huma by Dimitri. So just to have the opportunity for him also to answer her question, and then go back in the queue here so the others can ask their questions.
I was wondering how the work relates to active replication and distributed databases. So in your simulation, for example, you focus a lot on packet loss and network level problems. But what about, for example, things that are specific to databases like consistency of data and so on? Do you have any comment on that, or can you add to that?
Okay, so the thing is that the presentation was quite quick, so I forgot to mention about that we have actually considered the communication in the form, meaning the communication protocol that we have considered for the implementation is synchronous mirroring, where sequential writing takes place. That is, the primary mirror waits for an acknowledgement from the secondary mirror during the communication. So not specifically related to the databases, but when this kind of communication takes place. So our main uncertainty scenarios that we have designed are based on this kind of, meaning synchronous mirroring protocol, assuming that the communication will be done in this way. And when something happens in the network, for example, during the redundant topology, when a lot of, when we have more network links active, an unusual rate of data forwarding happens. So of course, considering the synchronous mirroring protocol, it will reduce the performance because we are measuring performance in terms of the time to write data. So, and of course, a lot of bandwidth will be consumed. So these are the kinds of scenarios that we have been working on. And of course, in an extension, we will be considering the other things as well. I hope I answered your question.
Yes, thank you very much.
Yeah.
Okay, so, oh, sorry. I missed time here. Thank you, Ingrid, for letting me know, guys. It should have finished at 10:25. Oh, sorry, my time, 25 past something. So unfortunately, I have to close here now this session, as we have the keynote, which should start now. I'm sorry. I was really distracted here with the questions.
Don't worry.